Right, today we are going to be discussing an important topic known as Chebyshev rules. If you watch my last video, I talked about empirical rules and how it is being used on normal distribution data. This is a very interesting topic. So concerning Chebyshev rule, you can use them with any kind of data set. Do not forget about the empirical rule which we learned last time, that they are only applicable on normal distribution data or symmetrical data. So Chebyshev rule is very unique because of the fact that there is no any data set you cannot apply it to, even normal distribution itself. But there is just only little difference about the Chebyshev rule, and that is the fact that it does not give a precise value. So everything about Chebyshev rule here will always be talking about at least, at most, unlike empirical rules that give a solution value. All right, let's see how it is being applicable to data set. What is empirical rule? What does it say? Empirical rule stated that, Chebyshev rule stated that at least 3/4 of data will lie within 2 standard deviations of the mean. That is, if you form an interval by deviating by 2 standard deviations from the mean, you will realize that at least 3/4 of data will lie between that range. Another way to state it is that you can say at least 75% of data will lie between 2 standard deviations. You can see both 3/4 and 75%, they are the same. You can also conclude that at least 8/9 of data will lie within 3 standard deviations of the mean. That means if you are deviating by 3 standard deviations using 3 standard deviations, you subtract that from the mean and you add that to the mean. These two values that you've gotten can be used to form a range and state that 8/9 of them will lie between that. You can also state that 88.89%, that is, if you are leaving your answer in form of percentage, you can see if you divide 8/9, you are going to get 0.888888, just like that. So when you convert it to percentage, you have 88.89%. So that's another way to state it. Now, how do you get all this value 3/4, 8/9? Because sometimes you are not going to be given a straightforward. This is the rule. Empirical Chebyshev rule states that at least 1 minus 1 all over k square of a data will lies within k standard deviation, provided that k is greater than 1. So that is the key. This is what we are saying. If this k can be any value, provided that it is greater than 1, then 1 minus 1 over k square of data will lie between it. This k is telling you the number of standard deviation being used, and this is the shortcut or short way to write the formula. S bar plus or minus ks. So this k can be anything, provided that it is greater than 1. So assuming this k is 2, that means we are saying we are deviating by 2 standard deviation. If you are deviating by 2 standard deviation, that means your range will be formed by saying 1 minus 1 all over 2 squared. This is it I have worked here. Look at this, what we have here. If k is 2, I will have 1 minus 1 all over 2 squared. So I will have 1 minus 1 all over 4. That will give me 3/4. So which is what I stated the other time about Chebyshev rule, that when you deviate by 2 standard deviation, about 3/4 of data will lie between it, or you multiply it by 100 and leave your answer in percentage. That is why you can say, so at least 3/4 or 75% of your data will lie between 2 standard deviation. If you are deviating by 3 standard deviation, that means your k will be 3. So if your k is 3, you are going to say 1 minus 1 all over 3 squared. And you are going to realize this thing will give you 1 minus 1 over 9. 1 minus 1 over 9 will give you 8/9. So that is why we said 8/9, or you probably need to multiply it by 100 and get the percentage, or 89.9 or 88.89% of data. You can see that will lie between 3 standard deviation. But do not forget the word at least, at least. at least is always used when you are dealing with Chebyshev rule. You don't have the precise value. Okay, let's take a look at the example. The mean of the height of 400 students is 69 inches, and the standard deviation is 2.5 inches. Between what height do not less than 75% of the students fall? How else calculate the minimum numbers of students expected to be between the range? In fact, the way this thing was constructed, you can see the question asked, between what height do not less than. These are the reason, or these are the points. These points are going to tell you that what we are actually dealing with is Chebyshev rule. Because this is not precise. This thing is not really asking you what is the height of students that lies, or this thing is not asking you what is the height or that is less than 75% of student for. It's asking you do not less than. So let's see. How will I deal with this? Is quite easy. Since I was given 75%, in fact, I know that this does not go with empirical rules. There's nothing like 75% in empirical rule. All I have in empirical is 68%, 95, 99.7. So saying the word 75% is in fact telling you that you are going to use Chebyshev rule. And what does Chebyshev rule state that relates with 75%? You can say talk about two standard deviation from the mean. So in that case, all I need to do is to deviate by two standard deviation from the mean. So my mean is 69, my standard deviation is 2.5. So we should add two standard deviation to this and subtract two standard deviation from this. And that is what I'm doing here. Mean minus 2 standard deviation will give me 69 minus 2 times 2. And that gives me 69 minus 5. I should add 5 also, I will get 74. So that means not less than 75% of students should lie between 64 and 75 inches. So that is the answer to the question. But that is not all. The question also asks that, well, we calculate the minimum number of students expected to be between the range. The minimum number of students, if you had that, that is actually telling you that they can be more than that, but they will never less than that. That means they are still talking about at least. So when you say not less than, when you say the minimum number, you can see you are still talking about at least. So that's what everything means. So in that case, they're actually telling me how many number of students are going to fall, how many number of students are going to fall between this range, 64 and 74, which I've calculated. And this will be very easy to solve, since I realized that at least 75% of them must lie between these two standard deviation. Then definitely I should just find 75% of the number of students. And what is the total number of students? I have 400. So calculating the 75% of 400 will give me 75 over 100 times 400, and that will equivalent to 300 students. So in that case, we should be expecting at least, or let me say the minimum value of students I should be expecting to be between that range is 300 students. So question easily done. Let's take a look at another example. In the University of Ibadan, if the mean of GPAs of students in statistics department is 2.5 and the standard deviation of 0.5, the question asks what will be the percentage of students have a GPA between 1.5 and 3.5. In fact, whenever you are given something like this is a form of range given, asking you to calculate the percentage. Note in Chebyshev rule, the examiner or the question might not even ask you for the percentage. They may ask you for the fraction. So if the fraction was asked, just know that you should leave your answer in fraction. Remember, there are two possible ways to write your value in Chebyshev rule. And inside they say about 3 over 4 lies, I would say 75%. About 8 over 9 lies, or you say 88.89. You can see. So whichever way, let's see. Now, looking at this question, I was asked what would be the percentage of students that have GPA between 1.5 and 3.5. So the first thing I need to know is how do I get this 3.5 using this mean and standard deviation? If you observe the mean and standard deviation, you realize that all I need to add to the mean is 1 to get 3.5. In fact, all I need to subtract from 2.5 is 1 to get 1.5. In that case, that means I will need to use two standard deviation here, because two standard deviation will give me that one. So now let's proceed and see how we do that. I will just write mean minus 2 standard deviation will be 2.5 minus 2 times 0.5. And that will equivalent to 1.5 if you subtract that. Mean plus 2 standard deviation will give me 2.5 plus 2 times 2.5. If you subtract that, if you add that to, you are going to get 3.5. So that means I'm deviating my two standard deviation to form the range, which is being stated here 1.5 and 3.5. Since two standard deviation was used, then I can confidently say that at least or not less than 75% of data should lie between that range, and which is the same thing as what the question has asked me. So I will just say like, according to Chebyshev's rule, at least 75% of data lies between two standard deviation. So that means 3/4 or 75% of the students will fall between 1.5 and 3.5. So that's the conclusion on that. But the question still asks another interesting thing. The question says, assuming the students are not allowed to graduate, if the student has a GPA less than 1.5, what would be the maximum number of students who are going to spend extra year if there are 100 students in statistics department? Now, observe this question well. The question is telling us that anything below this range, which is given before, 1.5 and 3.5 is what's given as the range and it was calculated. So the below this range, which is 1.5, you are not allowed to graduate. And that means you are going to spend extra year. So the question is now asking, what would be the maximum number? Now, let me tell you that unlike empirical rules, where you have a range being given already, and you have know the percentage that fall between that range, we usually say that subtracting that percentage from 100 will tell us the percentage of those people outside the range. So in that case, if 75% of students fall between 1.5 and 3.5, that is in fact telling us that 25% of them are outside the range. But do not forget, this is not telling us that exactly 75% are between this. In fact, all we have is that at least 75% of them are between this range. In that case, if you are going to propose for those ones that are not between this range, then you should not just make a precise value. So that means what I'm going to use should be opposite of at least, and that would be at most. So what I'm saying is that at least 75% of data fall between 1.5 and 3.5. And at most, 25% will be outside the range. And you get the way I've just input that. At least 75% are between this range, and at most, 25% will be outside the range. Because in fact, at least 75% is telling you that can even possibly be 88%, it can be 90%. And that is the reason why we should not precise about those ones that will be outside the range. All we can just say is that they are at most, that means they should never be more than 25% that will be outside the range. It is possible that those ones that will be outside the range will be less than 25%. But at most, or the maximum value we can have will be 25%. So what we are saying here is that those people that are going to have less than 1.5 GP, they are going to be at most 25% of them, or the maximum percentage of those that can be below this 1.5 or below this range would be 25%. And that is what we can denote from that. So that's what we are saying here. 25% of them should be outside the range in at most, do not forget. So if the maximum percentage that should be below 1.5 is 25%, that means we can easily calculate the number of students that score below. And how many are we going to get in that case? So we know that the total number of students in statistics department is 100 students. That means all we need to do is to find 25% of 100. And if you do that, 25 over 100 times 100, you realize that gives you 25. So that means the maximum number of students likely to spend extra year is 25. The question is easily done. Let's take a look at another example. Let me show you an example here. Look at this question. A sample of size n is equal to 50 as mean of 28 and standard deviation s is equal to 3. Now, without knowing anything else about this sample, what can be said about the number of observations that lies between 22 and 34? In fact, just like the way we did at the time, we realize that 22 and 34 are given here as the range. All I just need to do is to observe my mean and standard deviation to form any one of these. So looking at 34, I noticed I need 6 to be added to this mean to get 34. And in fact, if I can subtract 6 from this also, I will get 22. And that means my 6 will be equivalent to 2 standard deviation. That means 2 standard deviation is needed to form this range. And if 2 standard deviation is needed, remember we are dealing with Chebyshev's rule, because in fact, the question does not tell me that this is normally distributed. And that means all I have to do is to just use a Chebyshev's rule that talk about 2 standard deviation. And what was that about? Don't forget, the question Chebyshev's rule said that if you are making 2 standard deviation to form your range, then 3/4 of your data should lie between the range. And the question is asking us, what can be said about the number of observations? Please, you have to be very careful here. This is not asking for the percentage alone, but the number of observations. So in that case, I can just proceed and say, according to Chebyshev's rule, 3/4 of data will lie between this interval. Since I know that 3/4 of them should lie between this, then I can find the number of them that will be between that. Since I know the total number of observation is 50. So all I just need to do is to calculate 3/4 of 50. So if I calculated that, I'm going to get 37.5. You can try it yourself, but it does not make sense enough to say 37.5 of student or of observation will lie between two things. Instead, we should do approximation. So if you approximate this 37.5, you are going to get 38. So in that case, we can say the number of observations that will lie between the interval 22 and 34 will be 38. So 38 out of 50 are going to lie between this range, while 12 will lie outside this range. So the way to state it without making mistake will be that at least 38 observation will lie between 22 and 34. And at most, the remaining 12 will lie outside this range. So that is the way to state that. And that you can see what I have stated here. That is that about that. All right. I think we understand how Chebyshev's rule work. Yes, you can consider to subscribe. If you have any question, you can drop your question in the comments below. Also, do not forget to share. I believe you understand this perfectly. In my next video, I will be showing you how to solve different questions using empiricals and Chebyshev's rule and when to use them to understand better. Yes, keep on watching. Thank you. God bless.